Uh, Guys, just now I shared my screen. Can one confirm you can see my screen, right? Hello. Okay, fine. So this is episode 2. Okay. And there also I was planning some top 10 interview questions. So the mostly today, the top 10 interview questions are mostly on Java 8. Okay. So this is your last episode 1 questions. I think there, if you see the last 3 questions on completely on Java 8. So I decided to give some fundamentals of Java 8. I thought that maybe you have some knowledge on Java 8. But yeah, let's plan something from scratch from Java 8. And yeah, that's what actually the plan on today episode. So these are, the episode 2 questions. So completely on Java 8. So the first question, if you see the main features of Java 8. Next, second question, if you see how to prepare Lambda function. Because Lambda functions are, the biggest change in Java 8. The rest of questions, if you see, third question, consumer supply predicate function. Fourth question, forEach. Fifth question, optional. Sixth question, stream API. And seventh question, intermediate and terminate operations. For all, buddy, even the last question, if you see the flat map and map, for all, the base is second question answer only. Now, for all, the base concept is lambda expressions only. If you don't know lambda function, remaining concept you cannot understand today. Okay, so I was planned 10 questions. I mean, on completely Java 8 features. Maybe in the next episodes also, there's a continuation is there on Java 8. But today, the main focus on lambda expressions only. Okay, because there is a huge dependency is there for lambda expressions and the rest of all questions, which are listed on the down. Okay, I think we are good to go. Let's start the first question, buddy. The main features of Java. And Java is, the major change in all Java versions. Okay, and they introduce some lot of features here. So the first one, if we see Lambda expressions, today you're going to be seeing from scratch. Next, you can see method references. Maybe I can give you some high level on, Lambda expressions. First of all, what is a functional interface, correct? Guys, can anyone tell me what is my functional interface? Can anyone tell me what is functional interface? Uh, you guys are typing, right? I can see an answer. Yeah. So one abstract method, correct? SAM, I told you, right? SAM. And maybe in the last episode, I given that word SAM, single abstract method. So that single abstract methods, buddy, you can write in a simple way by using lambda expressions. And okay, today anyhow you are seeing from scratch. And method references, it's another way to call the methods by using double colon operator, double colon operator. Now, if you see the optional class, in generally we use a null literal to check the null references. Okay, but instead they given optional class. Today you're going to be seeing that as well. And functional interfaces, I think we discussed what is functional interfaces in the last session. And default static methods also the last session we discussed. And yeah, there's one more beautiful concept is there, Nastran JavaScript engine. That is also I'll show you maybe in the next episode. Stream API and Date API or implementation also will be there as part of Java 8. We'll see all from scratch. And next slide will help you, buddy, at least to remember, a few bullet points on Java 8 features. Maybe you can remember this 8 at least. If interview will ask you what are the Java 8 features, at least you have to tell at least the 3 to 5 you have to tell. In that, the first one you can see lambda expressions, method references, optional class, functional interfaces, default and static methods, and Nastran JavaScript engine feature, and stream and date API implementations. These are 8 features that you can tell every time in interview if they ask you. And buddy, let's start the second question today, lambda expressions from scratch. Okay, the second question is how to prepare a lambda function, lambda functions. Not only for Java, even if you learn JavaScript also, they given Lambda function. And even Python also, we have some Lambda functions. Okay, in almost in all programming languages, they given a Lambda function because when you write a method body by using Lambda expression, the code will become very small. I mean, the code will become very concise. So can you see the definition of, what is Lambda function? In general, Lambda functions are anonymous functions only, simply, I can say. Lambda functions are nothing but, anonymous functions only. 1 second, guys. Someone is knocking the door. 1 second. Yeah, sorry, guys. I'm back. Okay. And even if you're not aware with what is anonymous functions, anonymous inner classes, sorry, I'll go with again from scratch today. What is anonymous inner functions? And the main advantage, if you see, we have a concise syntax for writing inline functions. I'm pretty sure this word I'll make you proof. Okay, writing inline functions. Just note down the word writing inline function. And before we start uh, the Lambda function, we should have two prerequisites. One is anonymous class. Second is what? Function preparation wise. Anonymous class and function preparation wise. So the first we'll see what is anonymous inner class first. Actually, anonymous inner class is nothing but a local inner class without a name, without taking a name. We go for anonymous inner classes in generally to implement abstract methods from the interfaces and the abstract classes in generally. Okay, that's the advantage of the anonymous inner classes. And the next, if you see the prerequisite is function preparation ways. I hope this is you can remember all because in my C workshop I have taken this. Functions can be prepared in 4 ways: with arguments, with return, without return value, right? Without arguments and with return value, with arguments and no return value, and with arguments and with return value. So if everyone knows this two concepts, buddy, yeah, definitely we can understand Lambda functions, how to prepare from scratch. This time I was not showing you anything in the slide. I was planning to write, the code from scratch in Eclipse IDE so that I think people feel better. So yeah, so I was opening the first part of the code. Yeah, guys, can you see here what I did? I have taken a class with a main method. Don't get confused. I just taken a one class with some name with a main method, and your execution starts always from the main method only. Now about the class, can you please focus? I created one interface. Interface name is interface A. And since everyone knows, interface has only abstract methods. So I have a one method without body. Now, if you really want to implement this method, if you really want to implement this method, you have to take a class, right? Like this class, some class one, right? And you have to use a keyword implements, and then you have to write an interface A. Interface A, you have to take it because your interface name is interface A. And if you write this code, definitely you can see an error in the class name. You can see a error symbol in the class name. Can anyone knows what is that error and how to resolve it? Anybody knows? Anybody knows what was that error and how to resolve it? At least ping yes or no. Guys, don't waste your time and my time. Just tell me yes or no. No? Okay, that's fine. Okay, if any class implements any interface, if any class implements an interface, that class must implement this abstract method. Okay, that's actually the rule. So that's actually the error. So we should implement this method. So the implementation goes like this: public, the method header, and SOP. I was just in sysout, I was writing something, some logic X. Some logic X is going to be executing here. And nobody see the error is gone. Also, it's highly recommended to use @override annotation. Okay, so it tells to the compiler that we are doing a proper overriding. And don't think it's overriding concept. again, method overriding concept. This annotation tells to the compiler that we are declaring a proper method header, which is declared in this interface. That will check by this annotation. Let's say if you do any spelling mistake here, if you do any spelling mistake here, like see, I have written double ME. It's not a proper, you're not using proper method header. You're not using proper method header. This will give by this annotation actually. If you not this annotation now, you cannot see that error actually. Okay. So that's the reason, buddy, @ override annotation is mandatory. Just it will tell to the compiler that, hey, compiler, I was preparing a one method header, which is declared in this interface. So if I do any mistake, so just notify me. That's what we are annotating with the annotation called @ override. Okay. Now, buddy, yeah, if you want to call this method, if you want to call this method, so you have to going to be creating the object like this, right? Class one object is equal to new class one. This is a way we can create that object. And finally can call ob1 dot method one. This is actually one way to create an object and call the method, but it's not recommended. Guys, it definitely it's not recommended approach. The recommended approach is left side always you have to give the interface name. Left side always you have to give the interface name. And this is a proper naming convention up for object creation to call the methods which are declared inside the interfaces. Now let's run the code and you can see the output and the logic X will be executed. Now in this program, guys, in this program, maybe I'll write it this way. Yeah, in this program, let me highlight a few things. If you're not clear with what is anonymous inner class. Guys, we prepared this class, okay? And with open flower base and closed curly brace, if you see, this is class entry and this is a class exit. This class we prepared for only one purpose, to implement this interface method, right? This extra class we have taken, to implement this interface method only. Agree, everyone? Guys, just say yes or no in the chat. Quick. We created that class just to implement that interface method only, right? No, I didn't hear much acknowledgements. Okay. Now in Java, we have a concept called buddy anonymous inner class. If you go anonymous inner class concept, you need not to create this. You need not to create this extra class. You need not to create this extra class to implement this method. That's actually the concept of anonymous inner class. So let me show you that code now. In second example, guys, in this example, I was showing you with anonymous inner class. The earlier example you have seen without anonymous inner class. Nobody, I was not creating an extra class like how I created a class one here. I was not creating an extra class here. Let's see how I was implementing it. Okay, just write your interface name first. Just write your interface name. Now this time my interface name is interface B and space object equal to, okay, new interface name. Guys, can you answer it? Can we create object for interface? Yes or no? Quick. Can we create object for interfaces? Yes or no? Quick. Oh, I got answer yes. No, we cannot create object. And this line also, I written new keyword with interfaces, but it's not going to be creating object. You can see a compile time error. Yeah, I'm pretty sure you can see a compile time error. If you place the cursor over there, it will scold you. See, you cannot instantiate the type interface B. You cannot create an object. But before the semicolon, guys, before the semicolon in this line, if you write open and closed flower brace, okay, before the semicolon, if you write open and close the curly brace, now can you go back to the previous code? Here, this is opening class, this is a closing the class block, right? This is opening the class block and this is a closing class block, right? And inside this, we given a definition. Inside this, we given a definition. That is actually we are doing here. Just open and close the curly brace. so that compiler will create a inner class for you. This flower bases are nothing but compiler will create a one inner class for you without name. Without name. Earlier example, if you see, buddy, you have a class with a physical name, class one. But here, a class is created by compiler without having any name. That's the reason it is called as anonymous inner class. Now, in this flower basis, buddy, in this flower basis, like you written this implementation, right? This implementation as it is, you can prepare it. Yeah, as it is, you can prepare it. As it is, see, as it is, I did copy paste. Now, finally, you can call ob.method name. And this program also will work fine. This program also will fine. You can see logic X will be executed. Does that make sense? What is anonymous inner class now? Guys, does that make sense? Okay, now just what we did, we created a class. I told you, no, this flower bases are nothing but this flower bases are nothing but, sorry, not that flower bases, my bad. Yeah, this flower bases, sorry. This flower bases are, nothing but class open and class close. Anonymous inner class open and anonymous inner class close. And inside it, we are providing the definition of the body inside the body. I hope this is clear to you all. Now, the next concept is, let's say I want to implement this method one more time. Guys, listen the requirement. I want to implement this method one more time with logic Y. With logic Y. Then what we need to do? Just we have to copy the same code and paste it again. Then this time it will become object2. And this is one more anonymous inner class. This is one more anonymous inner class. And now we are implementing the same method with logic Y. And buddy, I was calling ob2 dot that method one only. Now we implemented this method twice now with logic Y. Now what if I want to implement one more time? What if I want to implement the same method one more time? Then you have to create a one more object and change the logic, and just you need to call ob3.m1 method. Correct now? So now what we did, buddy, same method we implemented three times. It means three anonymous inner classes will be created by the compiler at background. Three anonymous inner classes will be created at background. Let's run the code and you can see this output as well. So can you see logic XYZ 3 will be executed. Is that code make sense? Guys, is that code make sense? Okay. Now in this three programs, in this three method definitions, can you see here? This portion is common, right? This portion is common. Guys, please focus. You written the implementation. You given the implementation three times, but this portion is same. This portion is same for all three times. This portion include @override, public void, and their method name. Public void method name is common for three times, right? And one more thing I want to highlight here. Can you focus, buddy? The flower basis, the empty parenthesis will notify that this empty parenthesis notify that this method doesn't have any parameters. This method doesn't have any parameter, and the void indicate that the method is not returning anything. Now, the thing I want to highlight here, you implemented method one three times. You implemented the method three times with logic X, logic Y, logic Z, but why we have to declare the method header thrice? Why we can't provide a method definition? Why we can't provide a method definition like this, buddy? The square boxes. I was using the square boxes. Why we can't provide this method definition without the name of the method? Guys, the question is why we can't prepare the method definition without having the header? Without having the header. That's a concept of something, Lambda functions. So if you go to Lambda functions, if you go to a concept called something, lambda function, you can implement that method n number of times without taking this method header. Without taking this method header. That is, the concept of lambda functions. Yeah, if you go to the lambda function concept, you need not write the method header, but you can provide the implementation of the method as many times as you want. Does that make sense? Why we are going for a concept called lambda functions? Guys, yes or no? You're clear? Why we are going for a concept called lambda functions? Right. So, buddy, I want to repeat this again. Earlier, what we have seen, we have created one interface, and for interface implementation, we taken a class, right? To implement this method, only we have taken this class. And just now we learn a concept called anonymous inner class. Advantage of anonymous inner class is without taking this class name also, we can write the implementation. That's what we did it here. And now again in this one, the complexity is we implemented the method 3 times by taking 3 anonymous inner classes. And also here, the redundancy is nothing but we are keep on repeating the method header. Right? Again, to avoid that method header, we are going for a concept called something, lambda expressions. Now, buddy, let's see how do we write this code by using lambda expressions. By using, lambda expression. Now, same code I was taken. Now the interface name is interface C. Okay. In first class, I have taken interface A and here B and here the C. Now, buddy, here the method name is M1. Now let's see how do I implementing the lambda expressions. Yeah, this is the first example, buddy, I was showing you how to implement the lambda expression. So please try to follow some shortcuts so that easily you can understand. Okay. I think this is LAMBDA, right? First, write your interface name. Okay. Write your interface name, then write a object name. Write your object name equal to, guys, equal to. Now I told you, no, you need not write this part, right? You need not write this part. That's what we understand, right? In the previous example, we are keep on repeating this method header. Now, lambda function main motto is you need not write the method name, but you can write the implementation. So the implementation goes from this flower basis, right? So write the, sorry. The implementation goes from this parenthesis, right? So write the parenthesis as it is. Then write a arrow symbol, buddy. Arrow nothing but you have to use minus and the greater than symbol. Arrow nothing but you should write minus and greater than. Then you can write your flower base as usual. For providing the body, and semicolon is mandatory. Flower basis for body, hit enter, and buddy, you can write what logic you want to execute here like this. Now finally, you can call ob.method1 only. Earlier we haven't given a method name when you are implementing, and we know that this method has, we know that this interface has single method. We know that this interface has single abstract method, SAM. So when you do here flower basis, buddy, when you do flower basis, indirectly you are implementing this interface method only. When you do parenthesis here, you are implementing a logic for method 1 only here. That's actually the meaning. Now when you do ob1.method1, now let's run the code and you can see the output of logic X. Now can any one of you unmute and tell me how to write one more time implementation for this interface by using lambda expression? Can anyone guide me the steps? If any mistakes, I'll correct. Can anyone guide me how to write one more time implementation? Any one of you? Guys, can you hear me? Hello? Yeah. some logic, but different object name. Yeah, correct, Prasanna, but just can you guide it? I mean, the steps. No problem. If any mistakes, I'll correct it. First, what is the step you have to write? Okay, just change the object name. No, no, no. I was asking you to tell me the steps to write the code. Okay, anyhow, I'll explain again. First, you have to write interface name. Okay, then space object name equal to, and you can please watch the method header and see we don't have any parameters. So write empty parenthesis as it is, then arrow symbol, then flower basis, and semicolon. Don't forget to write the semicolon. I'll give a shortcut buddy to how to write the lambda expression here. After the object name, first parenthesis, then arrow, then flower basis, right? First you are writing parenthesis, then arrow symbol, then flower basis. Please remember the shortcut PAF. PAF. P for parenthesis. Okay. A for arrow. A for arrow. And F for flower basis. This is the order always you can remember to write the code. And inside the flower basis, buddy, you can write the logic. Which logic you want to implement. So indirectly, you are implementing the logic. One more time logic for the method one. So just call ob2 dot ob2 dot method one. Now, if you want to implement one more time, again, same thing you have to repeat. Write interface name. Write interface name. Just write, interface name. Just write interface name and change the object name. And as I told you, PAF is a shortcut, parenthesis, arrow, then flower basis and semicolon. And in flower basis, you can write the logic. You can write the logic. Sorry, you can write the logic and let me write logic Z. Logic Z. And finally, you can call ob3 dot, ob3 dot, the method one you can call it. Guys, can you see the previous example and this example? I'm pretty sure there is, more core readability compared to the existing one. Does that make sense? Guys, does that make sense? How to write lambda expressions now? Guys, can you please acknowledge in the chat? As I told you, for complete Java 8 features, the fundamental concept is lambda expressions. Almost 7 to 8 questions depend on only lambda. If you don't know how to write lambda expressions, yeah, remaining concepts will become tough to you to understand. Okay, right, good. Okay, fine. Now, guys, do you remember we have a 4 function preparation ways, right? In that case, definitely should know how to write the lambda expression. Definitely should know how to write the lambda expression for 4 different function ways. So that's what, buddy, I planned. One more example here. One more example. So can you see the first one? First interface one I have taken. Interface one without return type, without parameters. That's the first one, buddy. No arguments, no return value. Second one, if you see, with no arguments, nothing but empty parenthesis and return type. We have a return value, integer value. I was returning it. And next, if you see interface 3, you have taken without return type with parameters, right? That's the third one. And the last one, buddy, with return type and with parameters. So you should know how to write lambda expressions for 4. Definitely should know how to write the lambda expressions for 4. Okay, so let's start. Write the code, buddy, for the four approaches. Let me start the first one now. Interface 1. So first you should write interface name, then object name, then write the empty flower basis, empty parenthesis, since this method does not have any parameters, then arrow, then flower basis and semicolon. Now inside the flower basis, you can write the logic. We can write some logic, buddy. So just say logic 1 I have written. So logic 1 will be executed. Now if you want to call it, just you have to say ob1 dot, that method name you have to say it. Okay, this is the first approach without return type and with parameter list. Now the second one, if you see, second approach, if you see now, second approach, and 1 second, buddy, I want to show you something interesting here. Yeah. Now you may have a doubt. Can we write one line or can we write more than one line? Hey, you can write more than one line, buddy, like this. Yeah, you can write more than one line. You can write n number of statements inside the method logic. can write n number of logic. So let's run it and you can see this. Let's say if any lambda function, guys, a second example. Okay. Let's say if a lambda expression have single line of code, I mean single line of statement, then this flower bases are optional. This flower bases are optional. So you can remove them. You can remove them, and a single line you can write it. Yeah, you can write in a single line. Yeah, you can write in a single line. So this is maybe I was writing something, logic for to make just differentiation. That's what, buddy, I given in the paint one line for you. Maybe I don't know whether you remember or not. So can you see this? Lambda expressions, they provide concise syntax for writing inline function. Now I hope you are clear why they are called as inline functions. Also, can you see this? A lambda expressions enable you to treat functionality as a method argument or to create anonymous functions. Create anonymous function. That's what we are doing, no? Without name of the function, we are providing the implementation. Without knowing the name of the function, we are implementing this function, right? That's what, anonymous functions. I hope this is clear, buddy. If a function of single line of code, the flower bases are optional. Does it make sense? Confirm in the chat. Does that make sense? Okay. Okay, good. Now let's jump to the second scenario now. A method, I mean, second scenario with no arguments and with return value. With no arguments. So if you see here, this method doesn't have any parameter, but you must return some value. Let's see how to write that one. As usual, first interface name, then object name equal to empty parenthesis. PAF is a shortcut I told you. PF is a shortcut value. So can you see, buddy, here I have written PAF parenthesis arrow and flower, but you can see one a red color line here. So that indicates, it's a compile time error, and it's saying that this method must return a value. Can you see? If you place the cursor over there, it will tell you this method must return a result of integer type. Now in the body, buddy, in the body, you must return some value. So I was returning some 100. I was returning some 100. You have to return some integer value. You have to return some integer value. Okay. And I just now told you, right? If you are what do you call it as? If your lambda expression has single line of code, then is this flower base are mandatory for this? Guys, is this flower base are mandatory? No. Correct now? So then we can ignore this. Then we can ignore the both flower bases, open and close the flower bases, and we can write directly like this. We can directly also, buddy, if you have a single return statement, maybe I can write in these 2 lines. Maybe we can keep this code as this. Okay. Just do SOP of ob3 dot that method value. So definitely here you can see the answer is 100. Buddy, I'll rewrite the code again. I'll rewrite the code again. Now let me say this time I was returning 1000. Now let me call that method again. No, definitely it will also return 1000 now. If we say ob4 dot method 1. Now in this case, guys, carefully observe, in this case, I have a single line. So I told you flower base are optional. Also have a single return statement, correct? I have a single line of return code. Then return keyword is also optional, buddy. Then return keyword is also optional. So you can remove the return keyword as well. Directly you can write like this also. Single line statement also you can write it. Okay. Now try to observe this. Try to observe this. You can see this output. You can see this output. Both outputs you can see. So what I want to conclude, for your lambda expression, if you have a single line of code, flower base are optional. And if you have a single line return statement, if you have a single line return statement, then the flower base are optional, and as well as the return keyword is also optional. Here we return a return and flower bases. And here in this example, if you see, I just ignore to write return keyword. I just ignore to write the flower bases as well. I hope the first two are clear to you all. Guys, confirm in the chat. Okay. Right. Now let's jump to the third scenario now. I mean, with arguments and no return value. With arguments and no return value. Now in this case, I'll try to take, yeah, this one, right? Interface 3, right? Which has one integer parameter, Let's see how to write it. First interface name, then object name, then flower basis, arrow symbol, then flower basis. And but as per the definition, see, it has one parameter of integer type. So let me write, let me take one integer variable. The variable name is x. But the advantage of, one more advantage of, your lambda expression is you need not to declare its type. Just if you write x now, that x will become integer type only. Okay, x will become integer type only. And what you want to do by x, you can write it, buddy. Just I was doing x plus some 999. Just I was passing x plus 999. Now let's call that obify dot that method, and you can pass something. One I was passing, guys. I was passing one, so that you can see the output is 1000, because 1 plus 999. Sorry, 1 plus 999. Yeah, the answer is, you can see 1000. The answer is, you can see 1000 here, right? And this is something, your lambda expressions, how to write for with arguments and with no return value. And one more interesting I want to show you here. We have a one parameter, right? Guys, we have a one parameter, right? If you have a one parameter, okay. If you have a one parameter here, then this parenthesis, buddy, optional. This parenthesis is optional. If you have a single parameter, the flower bases are optional. Okay, so you can ignore to write the flower basis, and still, buddy, you can write the implementation like this. You can still, and as I told you, if you have a single line, then this flower base also not mandatory. Not mandatory, as I told you, right? So see, buddy, how simple I have written x arrow SOP of x plus some value I have given. Now it's calling ob6 dot that value. So you can see that output as well. I think the output is 1 lakh maybe. Yeah, it's a 1 lakh. So this is something, if you have a single parameter, the flower base are optional. Sir, what if the method has two parameters? Yeah, if the method has two parameters, no, let's take, buddy, for this scenario, let me take two parameters. If you have a two parameter, definitely the parentheses are mandatory. Let me read the last example now. Let me write down the last example now. So interface name, then object name equal to parenthesis, arrow, and flower basis. Now we have a two parameters. No, let's take a comma b. Now a comma b is nothing but this a comma b, buddy. Okay, into data1, data2. Now what it expecting? It should expecting one integer value, return value. So just you can write return, buddy. I want to return multiplication of both a and b. So just now I did this one. I just did this one. Now call that method by passing ob method ob7 dot method 1 of let pass 5 comma 6. I'm pretty sure this will return the multiplication of 5 and 6. That's what 30. The answer is 30. Can anyone minimize this code, guys, or else can one say, can I minimize this code without writing the return keyword? Can I minimize the code? Guys, tell me yes or no. Can I minimize the code? How? At least you can type it. I don't know why you are not unmuting. That's okay. But at least tell me, how do I minimize this code? What things I can remove it from this code? Yeah, correct. Mahendra. Yeah, and Raj. Oh, you both have given two different answers, right? The both we can club and I'll tell you. So buddy, if you have a single line, written line is optional and the flower base also optional, I told you, right? Yeah, maybe I'll copy this code. I'll write one more object this time, object 8. So as you told me right just now, this flower base are optional, return keyword is optional, right? Right? And directly you can write ob 8.5 and 6. Let's run this, and here also you can see the same output. See. So that is the answer. Guys, is that make sense how to write arrow functions in 4 ways? Okay. But I know how, I was still straight, second question, but I told you the only second questions will give you, the answer for remaining all the questions. Okay, let's jump to, buddy, the third question today. Third question today. So far we discussed, buddy, how to prepare a lambda functions. I mean lambda expression. So we have almost practiced all use cases. Almost all use cases. If we practice about the lambda expression, now it's time to understanding, remaining question answers, buddy. So third one we'll see explain about consumer, supplier, predicate, function, functional interfaces. And don't much think by seeing the names because they're all ready-made interfaces. They're all given in Java 8. And if you want to use the 4 functions, buddy, they are belonging to java.util.function package. And the main advantage of the 4 functions is they're widely used. I mean, they're much used in stream APIs. They're much used in stream APIs. Maybe the next episode, maybe I'll cover, all stream related operations. And the first one will start something, but consumer. Yeah, first we'll start something, consumer. Okay. And here, don't get confused. What is this consumer supply predicate function? Can you please have look at my code? Look at my code here. Interface 1. It's a SAM, right? Single abstract method. It has it, and which has a one method which not taking any parameter and not returning any value, not taking any argument, not giving any return value. Second one, if you see single SAM, not taking any parameter but returning some integer value, correct? And third SAM, if you see this method, taking one integer and not returning anything, taking one integer and not returning anything. Now third one, if you see, buddy, it taking 2 parameters, but it and also it returning some value, taking 2 parameters and returning one integer value. You understood, right? What I have explained. Similarly, this 4 functional interfaces has some SAMs, buddy. Nothing but single abstract method. Don't get confused. The only thing you have to buy hard this chart. Yeah, trust me, you have to buy hard this chart. Definitely introduce, definitely they will ask you. You can remember the shortcut like this. So you can remember PT. You can remember PT and you can remember CA and you can remember FA and you can remember ST. Yeah, this shortcut, buddy, you have to buy hard it. PT, CA, FA, and ST. Definitely you have to buy hard it. Now let me read out what is it. P for predicate is an interface which has a abstract method. The method name is test. And can you see test method taking one parameter and it must return a Boolean value. It takes one parameter and returns a Boolean value. Next, C for consumer. Consumer functional interface has one abstract method. The method name is accept. So can you see it take the argument, not return any value. It will not take the argument. I mean, it will take the argument, but not return any value. And third one, if you see, buddy, third one, if you see, it will taking the parameter like function interface. The method name is apply. So it will take the parameter. It will take the parameter and return some value. Return some value. And the last one is get method, which will not taking any parameter, but which return one integer value. I know it's very difficult to you, but you have to buy hard it, buddy. No alternate way. You have to buy hard the shortcut PT, CA, FA, and ST. Or else you can remember this way: PT, ST, CA, PA. I mean CA, FA. Like that, buddy. You have to remember this. Now, only thing you should know how to implement this logic. Can you take a screenshot of this? I hope you're done, right? I hope you've done the screenshot. Now let's see, buddy, how to write the implementation for this. First, I'll show you for predicate, or else, yeah, we'll go with consumer. Hmm? So I created one more package for the question 3. So go to the question 3. First, we'll see consumer. First we'll see consumer. But yeah, I have created a class. The class name is consumer example 1. I think let me mark. Let me remove this marking once. Okay, that's okay. Yeah, can you see, buddy? I have created a class with a main method and just declare a consumer. And consumer is one of the abstract method. And I just given you the shortcut that you have to remember. Consumer interface method name is accept. Consumer interface method name is accept. Guys, can you tell me what are the steps I have to write now? This is interface name. And if you want to see its method also, hold the control key and click on that consumer so that you'll go inside. And can you see here? This is a functional interface which are generated with functional interface, and it is given in JDK 1.8 version, and it has only one abstract method accept. Okay, and remaining one more method is there, and then, but this is default method. I think last session we learned it. A functional interface can have n number of default and static method, but it should have only one abstract methods. Okay, this is the only abstract method that we are implementing now, accept method. Yeah, can you guys tell me what should I write here? What is the shortcut I have given to write it here? Equal to, what is the shortcut I have given? At least, can I have the alphabet series in the chart? I given the alphabet series to write the code. Yeah, PAF, correct, Navin. Right. So first parenthesis, then arrow, then flower basis. Now, can you please, and you have to remember this method, buddy. Accept method you have to remember. So it should have a parameter. It should have a parameter. So the parameter you can take X, you can take parameters X, and if what you want to do by that X, you can do it. So I was doing some X plus 10, and into X. Array, some operation I did it. Some operation I did it. Or else let me do, buddy, X plus 10. And also, I forgot to tell you here, if you go to the consumer, yeah, it accept one value. It accept one value. 1 second, buddy. Showing something. Okay, I understood what is the problem here is. Guys, am I declare the type of this X here? Can you answer this? Am I declare the type of the X here? No, correct. So we must and should declare, buddy. That's the reason it's showing this. Who's a parent class for all the classes in Java? Who is the parent class for all the classes in Java? Correct. Object class, na? Yeah. Now your X is object type, buddy. Your X is object type. You're right. Now we have to tell that what type of parameter you require. So I was taking as a generic, integer. Now the X value will become integer. Now, if you want to do any operation, you can do this. You can do this. Now just do SOP of that OB dot. Yeah, method name is accept. And you can pass something, let me pass something, 900. So I was accepting 900 here. I was printing, I was giving the values 900. Sorry, buddy. I think it's a bad call. It's just a bad call. Just you have to say OB dot that accept. I told you, consumer interface have a method name is accept. CA is a shortcut. CA, consumer interface method name is accept. Now what this Lambda expression is doing here is, we are passing 900, buddy, 900 storing into this X, and what you're doing, 900 plus that 100. So 1000 will be returned. Let's say you want to work with string now. Guys, you want to work with string now. Then you should say consumer string type, then another object. And now your parameter X will become string type. Hmm? Your parameter string will become string type. And buddy, here, if you want to do any work, you can do that. So I was doing X dot to uppercase. X dot to uppercase. So this time when you call ob dot accept, let's say, yeah, ob1 dot accept. Now you should pass a string value here. So I was passing something, Chanti in lowercase. Okay. Now if you run the code, you can see in the output as uppercase C. Also, buddy, you can reduce this code, right? You can write in a single line as well. You can write in a single line as well. As I told you, if you have a single line, the flower bases are not mandatory. Like that also you can do this. Okay, this is something, consumer. Does that make sense? Guys, does that make sense? What consumer is doing? And if you want to really write this kind of code, you should remember the method name. So consumer functional interface method name is accept. So this accept method will accept one argument, and perform some logic on it. Accepts as a parameter and perform some logic in it. See, it accepts the argument and perform some logic here. Okay. Now let's jump to the second functional interfaces. Second interface, that is supplier. Guys, general meaning of supplier. General meaning. So just stay with the same meaning. Just stay with the same meaning and hold the control key. Go to the definition. So as I told you, it's a functional interface and it has, it is introduced in JDK 1.8. And buddy, this is a method get. So supplier interface method name is G for get. So can you see the definition, buddy? This method header, the method always returns some value. It always gets a result. It does not take any parameter. It always returns some result. Now let's see, buddy, how to implement that get method. Same shortcut, empty flower basis, arrow, and empty flower basis, sorry. And I told you it must return some value. Get method, supplier always return some result. Supplier always return some result. Okay. So now let me return some 100. And when you are returning 100 to the supplier, you have to tell. To the supplier, you have to tell. So in Angular basis, you can tell that integer. Otherwise, it will become object type, buddy. Otherwise, it will become object type. You have to specify. Now let's say for supplier, you want to tell that as supplier return string value. Return a string value. So then you can say supplier string and ob2, and now this time you have to return some string. You have to return some string. Okay, and buddy, let me call that method. The method name is ob1 dot. I told you you have to call a get method, and supplier will not take any parameter and always return some value. Supplier won't take any parameter but always return some value. So first ob1 dot get will return 100. Second ob1 dot get return India. Let's run it and check this output. I think I did a bad call. Should do ob2 dot get. Sorry. Let's run this. Yeah, see guys, you can see expected output. Okay, I think this is supply. Let me repeat you again. The first one is consumer. Consumer will take the parameter and do some business logic on it. Supplier won't take any parameter, but always return some value. Always return some value. And you have to declare that value, what type of value you are returning it. Let's jump to predicate. It's very interesting actually, predicate. Now, the predicate interface I declared it. Again, hold the control key, go in it. Yeah, it's a functional interface. And it has one abstract method, test. Predicate functional interface has a test method, which has a lot of default and starting method. It's okay. You can forget about the default starting method. Focus on the test method. But I told you the test method always take one object, take one object, and do some business logic in it, and the business logic must return the Boolean value. Take the parameter as one object, take the parameter one object, and do some business logic, and the business logic must return a Boolean value. Okay, so now let's start write the code. As I told you, it should take one parameter. Okay, it should take one parameter, and you should declare what type of parameter it is here. So I was declaring integer. Huh? I was declaring, integer. I was declaring something, it's an integer. Sorry, this has to declare here. Yep. Now, as I told you, buddy, you should take one parameter. The parameter name is I have taken some x. Now I told you, you have to do some business logic and you have to return a Boolean value. Now I want to check this x is even or not. So on this is the logic we have to return, correct? Na? X mod 2 equal to 0. So I was returning a Boolean value. I was checking whether it is a Boolean or not. I was checking whether it is in a Boolean or not. Now let's try that. SOP of ob dot. I told you method name is test and pass 199. We know that it's not an even, and let's pass 190. Yeah, it's an even number. Now you can see the Boolean values true or false. Okay, just you can see the true or false. True or false. Now I want to check whether the string is empty or not. I want to check whether the string object is empty or not. Okay, so then for predicate, you have to take string type object. You have to take a string. You have to take a string ob1, and yeah, now the x will become string object. X will become string object, and the method name is right to check whether it is empty or not. To check whether it is empty or not, just you need to call a method something sorry, the spelling is wrong. Predicate, yeah. Just you can call the method name is sorry, x dot. You can check the method name is empty. You can check the method name is empty. Okay, so this method will return a Boolean value. Now let's call ob.test. ob.test. Now let pass empty string body now. The first time, right? We can pass empty string now. Okay, empty without any single space as well. Now let it give one space and let give a name. Let's give a name. So first time definitely return true. Remaining times it return false. So predicate always take one parameter and perform some logic, and finally it has to return Boolean value. That's what your predicate. And the last one, guys, that's what your functional interface, function interface. And if you go inside it, you can see one abstract method. The method name is apply. So this apply method always take the argument as an object and return one object. Always take the argument as an object and return one object. Okay, so let's try to apply it quickly. Yeah, here you can write parenthesis, arrow, and flower basis. And as I told you, buddy, it should take one parameter. And you have to tell what type of parameters. Let's take string parameter now. Let's take string parameter. And now we have to tell what type of argument we are passing. Let's say x is an object. Let's say, x is an object. X is, object. I think we have to give two parameters. I think target type of this function parameter was to be functional interface. Okay, fine. So I was returning here x dot. One second. Let's go to the definition once. Param t is the function argument, and this will be the result, right? That's what we did. So it should have two parameters. Okay, I understood. So we can say x dot, let's say length, and then do SOP of the method name is apply. So b1 dot, you can call a apply method, and let's pass chanty, and definitely it has to return something. 6 is the output. Yeah, 6 is the output. Don't worry, buddy. What is this? I'll explain you. So when you are working with function interface, you have to tell two things, buddy. The first parameter, first generic, you have to tell that what type of parameter you are passing. What type of parameter you are passing. So my parameter should be string now. See, chanty I was passing. So x will become chanty. Now second generic type will be buddy integer. Now I decided to send number of letters in that string. Now I decided to send number of letters in that string. So the number of letters nothing but integer, no? That's what you have to say. So you can see return x dot length is nothing but it return an integer value. So that's what you can see the output is 6. So I want to repeat this. Function interface method name is apply. So when you're declaring function, you have to give two generic types. The left side will be your method parameter type, and the second generic type should be, what type of return value that you are returning it. So that's what about, your functional interfaces. As I told you, but if you have a single return statement, then flower basis and the, your return keyword is also optional. So we can do like this as well. So this also will give the same result. Let's go back to the slides. I think guys, so far we discussed only, there's 4 functional interfaces. I think, buddy, the next slide, next session, maybe I'll cover, the remaining operation. And I'm pretty sure the one who practice this, the Lambda expressions and all, next session, remaining questions will become easy to you, buddy. The remaining all questions will become easy to you because they are all depend on Lambda expressions only. Any queries? Okay then. Bye guys.